Hello everyone. Today we are going to solve another medium level lead code problem of longest substring without repeating characters. We will solve this problem with the systematic approach that we have discussed in our previous video. If you have not watched that video yet, I'll link that video in the description and in the icon above. So without further ado, let's get started. My name is Aditya Shenoy from Brainy where I make programming simple and fun. The first step to solve any competitive programming or a technical interview question is to understand what's the problem. And the problem statement is mentioned in the first paragraph or the first sentence of this page. It says, given a string s, find the length of the longest substring without repeating characters. So this is the only description that we have for the problem. Instead of directly writing the code after hearing this problem, we will go to the next step of the systematic approach, that is the assumptions and constraints. There are two types of assumptions and constraints. One is related to the data structures and one is the value stored in these data structures. So here the data structure is an array of characters, that is string. So the data structure constraint should be whether the string, that the input string that we are given, can be empty or not. And in this example 4 we can see that the input string s can be empty. So that is one of the constraints that we have given, that is the string can be empty. So our algorithm should be able to handle that. The second type of constraint that we can think of is the constraints related to the value stored in those strings. So what kind of characters are we expecting here? And here when we ask this question, our interviewer might say that it can contain English letters, digits, symbols and spaces. And also one more constraint that is mentioned here is the length of the string. So it can range from 0, as we have just seen, to 5 into 10 raised to 4. So our algorithm should be optimized enough so that it can handle the input string of length of this order. So now comes the next step of the systematic approach, that is the baby approach. Baby approach is the brute force approach that we can think of to solve this problem. We need not write this code, but we can at least think of the algorithm and approach and its complexity. If I was at the age of my childhood, I will go for all the combinations of substrings that I can find here. So that, for example, like A, then AB, then ABC, then ABCA, and so on. And I'll see whether there are repeating letters in them, and like whichever string substring is the maximum here, I can say out that answer. So in this algorithm and in this approach, what we have done is we have first decided on the combination of the substrings, and this substring is dependent on the start position and the end position. So we are trying, in the brute force approach, we are trying out all the possibilities of the start and the end position. So there will be two nested loops, one to iterate over the start positions and second to iterate over the end positions. And even when we get all the combination of substring, for each substring we have to check whether there are duplicates present or not. And if one of the substring combination is this, then to check whether there are duplicates or repeating characters in this or not, we have to check for each letter and check with all the remaining characters whether the current character matches the others or not. So there will be in total 4 loops which will have complexity of O of n each. So the brute force approach complexity is O of n raised to 4, which is not at all optimized here, and we can do certainly a lot of optimizations before we actually even write the code. And the space complexity will be constant for this approach because we are not storing or saving any extra data structures in the order of the input. We will be storing some variables, and those variables will not be dependent on the number of characters present in the string. So the space complexity of the baby approach will be O of 1. Now once we have the baby approach or the brute force approach, we can move on to the next step of the systematic approach, that is the manual approach. So in this step I will think, if I am given this problem without the help of computer, how will I solve this? If I am given this string to check for the longest substring without repeating characters, I'll start with the starting character A and I count the letters till I get one more repeating character. So I have seen A, B, C, and once I get A, I know I have seen that letter. So my this substring is resultant to 3. Similarly, I'll go to the next letter B, C, A, and B is repeating, so my answer for this substring is 3, and so on. So for each start string, I'll try to find the end string till I don't get any repeating characters, and I'll also store the result, that is the maximum answer that I am getting up till now. So this will be the approach that I will follow, and once we have the manual approach in our mind, we can go to the next step of the systematic approach, that is to actually code. So in this code we are seeing a function definition which takes just one parameter, that is the string, and it returns an integer, that is the length of the substring without repeating characters. So that is very straightforward, and as we just discussed, we have to iterate for all the start positions, starting from 0 to the entire length of this input string, that is S. And for each start position, we will determine the end position. We have to keep track of all the characters that we have seen up till now. So I have to create a set that will store all the characters that I have seen up till now, and I'll try to find the end position starting from the start position. Maybe there is only one letter, for example in this the answer is just 1, so my end position can be equal to start, so I have to start from here to the end of the string, that is the length of S. For each of the ending character, I'll add that character to the scene set, that is scene.add. I'll add the character at the end position. But before adding that, I have to check whether this current character is already seen or not. So before adding this, I'll add if the current character at end position is already present in the scene set. If that is the case, I'll break out of the loop, and whatever is the length of the scene set now, that is my current winner. That is the current length of the substring starting with the start. If my current start is 0, my starting character will be this, and it will store 3 characters in the scene set, and when I stumble upon this A, it will break out of the for loop. So, and it will not add this because before adding we are breaking that, so the number of characters stored in the set will be 3, and that is the maximum, that is the length of this substring in this case. So the length of the scene will be stored as our result, but we have to keep track of the maximum result. So outside of the loop, before checking for all the combination, we have to initialize the result as 0, and before updating the result we have to see whether it is more than the current result or not. So result will be set as the maximum of the result that is already leading in this, or the current length of the scene set. And once I check for all the combinations and store the maximum result, I can return the result. So this is the exact manual approach but written in the code. Now we can test it out by running our code for these examples, and it is accepted. So I can try submitting for testing with hidden cases as well, and it is accepted. Now to understand the time complexity and the space complexity for this, what we have is a loop which will try for all the combination of start. So this loop will run for the number of characters that are stored in the string. So this is O of n here, and even for this end position, even though it is not traversing the entire string, it is still in the order of n. As there are two nested loops of O of n each, the time complexity of this manual approach is O of n square, which is still a lot better than O of n raised to 4 that we saw in our baby approach. And here this complexity is O of 1 because we are using a set, and to check whether a character is present in a set is a constant operation. So that's why we have not stored this as a list and as a set, because checking whether a value is present or not in a set data structure is a constant operation, and that's why it does not add up to the complexity here. So the final time complexity of this approach is O of n square. The space complexity arises because of this data structure that we are using scene, and that is O of n. At most n characters can be stored in the scene set, so the extra space or extra data structure that we are adding here is O of n. Now, even though this is accepted, the interviewers might ask that whether there is more optimization possible or not. So this leads us to the next step of the systematic approach, that is the manually hard approach. Now, up till now we have seen inputs which are like 10 characters or less than 10 characters long. Our constraints say that this input string can have this many characters, 5 into 10 raised to 4 characters. So if we are given an input string which contains a lot of characters matching this 5 into 10 raised to 4, will we solve the problem with the same approach manually without the help of computer in the same approach? That means if we are given a hard problem, will we solve this problem, this hard problem, the same way as we have done in the manual approach? Most likely not, because your brain will try to optimize the solution or the approach based on the complexity of the problem. So if we are given a very large problem, so instead of solving this problem by taking all the combinations of start and then figuring out the end, there is a catch here. So in this approach, when we are starting with this starting position A, we reach 3 characters when there are no repeating characters. But when we reach this next character A, there what we do is like we are resetting, like we are storing the result 3, but we are resetting all the progress that we have. So instead of that, what if we just remove the characters till A? That means instead of forgetting everything between this A and this A, that is BC, we can still have the characters BC, and as we have removed A, we can start with this, the next character, and again we reach a B. So instead of that, we will remove all the characters till B, and so this is our third approach. So you can see that we are not repeating our progress because we are already storing some of the characters from the previous iteration, and we are creating a window of the start and end. So this is a sliding window mechanism where we are storing a start and end, and as the end reaches some condition, we are also moving the start so that the end can be expanded. And with this approach, we are actually saving some time because this window will have some overlap with the previous window, and that's why like we don't have to repeat our task again and again. So I'll reset this code, and what we will do is we will start the window at 0. Initially the window will have the starting point and the ending point at the start character. So but we have to move that ending character, ending position of the window to the right. So we will have a loop for that, for end in range, which will start from the start position and it will end at the length of the string, like this. And in this we have to also keep track of the scene set just like before, but instead of having that inside the loop, as we have seen that we are repeating, we have some overlaps between the iterations. So instead of recreating the scene set in each iteration, we can have that outside the for loop. That way we will not forget everything once the iteration overs, and we will still keep some of the elements that are overlapping in this case. So for end in range start len of s, what we will do is for each possibility of the end, we will add this character at the end position to the scene set, just like before. But in this case, when we reach the condition where we have encountered a character which is already present in this set. The way we have done it before is like this: s of end is present in the scene set. We were breaking out, but instead of that we can remove the characters from the start, s of start. That way we will not remove all the characters from this set, and we will have all those characters which are overlapping between these two Windows iteration. And this will not work because it will only remove one, because we are using if. So instead of if, we have to use while. So while the ending character is already present in the scene, we have to remove that start character. And once we remove the start character, we have to move the Windows starting position one position to the right. So we have to increment the start position as well. And once we have removed all the duplicate characters from the scene set with this while loop, and we have added the current ending character of the window to the scene set, we can store the result in the result variable. But for checking all the combinations, we have to initialize the result first outside the loop with 0. And here we will take the maximum of whatever the previous result was and the len of scene set, like this. So for example, when we are reaching this point where we have ABC in the scene set, there is no, until this point the while loop will not work because we have not seen any duplicate characters up till now. But for the next iteration of the end, when we reach the A character, we will have that A character already seen. So the while loop will remove characters from the start, and we will be left with this BC in the scene set. And after the while loop, we will also add this A to the scene set. For this iteration, the maximum answer is 3. And so the len of scene is 3, and whatever result we have already, we will store the maximum in it. And after checking all the combinations in this loop, we will return the result once the loop ends. We can test this code for these examples, and it is accepted. We can submit it for testing it with hidden cases as well. And our answer is accepted, and this solution is much faster than our previous manual approach, and it is also storing less memory because we are keeping only one set outside the loop. Coming to the complexity of this manually hard approach, we can see that there are 2 loops. So the natural instinct will be to say that the time complexity is O of n square, but that is not the case, because if you think of the approach without these loops, the start position is moving from start to end, like the start of the string to the end of the string, and also the end position is also moving in that way. So for each end, the start will also follow it. Instead of the complexity of n square, this complexity is O of 2 into n, which is approximately O of n here. So this solution is O of n, and you can also see that difference here because the earlier solution was O of n square, and here the current manually hard approach solution is only having runtime of 64 milliseconds, and that indicates that the time complexity has reduced, and so the time complexity in this case is O of n. Coming to the space complexity, we have only one scene set, which will have at most n characters if all the characters in the input string is unique. So the space complexity is O of n again. That has not changed. So in this way, we have solved the medium level Leetcode problem of longest substring without repeating characters. We will be solving more medium level and hard level problems of Leetcode on this channel. So please subscribe to see those videos in future. If you found this video helpful, please click that like button. Comment any feedback that you have about this systematic approach or in general about the channel. You can connect to me via LinkedIn, whose link is in the description. And there will be some videos on the screen right now that you can watch next. And I will see you in the next video.